What's up, everyone? If you're building AI systems and want them to work reliably in production rather than just be demos, then this video is for you. In this video, we'll show you how to implement factor one of the 12-factor agents methodology. If you don't know who we are, I'm Dan McCauley, AI engineer, and this is Dave Odell.
Hi, I'm a DevOps engineer.
We've both been building software for over 20 years, and we've been focused on building out AI agents for the past year. So I'm going to start by talking about 12-factor agents. 12-factor agents is built by Dex at human layer, and it's a foundation of methodologies that help build reliable LLM applications. He's been working with a number of other engineers to pull together the principles that they've been using over the past few years for building their agents. This methodology is based on the 12-factor app, which was all about building reliable web applications. This came out 10, 20 years ago.
Some really core things like logs should be streaming. There shouldn't be big differences between dev and production, and always use environment variables for all of your configuration. So those are some like bedrock things that are 20 years old and they still stand true today.
Awesome. All right, so we're going to start today by going over factor one, natural language to tool calls. We're going to go through three different demos. One is just an LLM to a shell command, no tools involved. Then we're going to introduce tools, talk about the benefits of what the tools are doing for you. And then finally, we'll talk about agenic workflow that uses tools. All right, so now we're going to walk through the first one. So in this first one, we created a CLI. So you pass the user request to the LLM generates a shell command. We confirm whether or not we should execute that command. User checks to make sure it's correct and valid, then we execute it. Otherwise, cancel, and then we exit the application. Very straightforward. Now I want to walk you through the code. In this code, we're using Claude. You can use any LLM. All the principles apply. There's slightly different tweaks when you're actually interacting with the LLM, but the core principles are the same. All right, so here's the system prompt. You are a helpful assistant that provides shell commands. Give only the command with no explanation or markdown formatting. And we have this extra sentence to make sure that the LLM doesn't send us anything other than the command. This works most of the time, but we'll show you how tools can allow you to remove that extra sentence. We take the user prompt here. We pass it into the LLM with the system prompt. We capture the input and output tokens and calculate the cost. And then we prompt the user. We ask them if they want to execute the command. If they say yes, we do so. Otherwise, we exit. All right, now I'm going to pass this over to Dave. He's going to walk you through the demo.
Yeah, hi everybody. So this is the most rudimentary example. So there's no validation, there's no defaults, there's no safety checks. This is just a straight up simple prompt going into this tool here. And I have two examples here. First one, we're going to create a bucket, and then I'll show you how you don't want something like this in production. And I'll show you why in a second. So we're just going to say the command is create a bucket named AppVitals01 in Oregon. So we're not specifying US West 2. We've got a little bit of code in there, and we're hoping the LLM comes back with US West 2. Looks pretty successful. Let's run it and see how it goes. Okay, did it create it? It did. Okay.
Awesome.
But like, this is like demo quality. This is not production level because I can take a command, even though this thing was designed to create buckets, I can take a prompt like this, fetch the GitHub homepage, and run it. And there you go. It's got the curl command. Let's run that. Okay, so this is great for demo, but as we get further on in our demos, we're going to show you some things you want to put in place, some guardrails, some validation, so that we're getting closer to a more of a production level application.
Sweet. All right, I'm going to go ahead and walk you through the second example. So in this second example, we do a couple of things. We add defaults, and then we introduce tools. So it's very similar flow, but we'll walk you through it. The user enters a prompt. The LLM analyzes the input. It chooses which tool to execute. Then the user still confirms whether or not we should execute it. When we're changing something, we're pretty firm believers that we should have a human confirm it. There are cases once you get confident enough that you can have the LLM actually modify in your database and things like that, but especially in this phase, we're not there. Once they confirm, execute the command or cancel. So very similar. We just added a couple new things. So I want to walk you through the defaults. So in this case, since we're using LLM, we decided, all right, why not? Let's use Markdown for the configuration. It's very good at translating natural language to code. So we've added this cloud bucket configuration Markdown. It has a default provider, default prefix, and then region defaults for both AWS and Google Cloud. So we introduced Google Cloud in this one. Now I want to walk you through the code. Initially, we read the project settings. We change the system prompt since it's dynamic. We load the project settings, whatever they are, and we say, all right, here are the two tools that you can use. You can either create an AWS bucket or a Google Cloud Storage bucket. And then it has a procedure here. This is mostly all about reading those settings and defaults and how you should integrate that into the tool that you end up calling. All right, we pulled execute command out into a separate function. So this is the same thing that we saw before. We confirm that the user wants to execute it. If they do, then we execute it. Now we have these two tools, which are relatively simple, but in this case, the LLM is only sending us the bucket name and the region. They're not generating the entire command for us. And we know that if you generate in US East 1, for example, you can't send this location constraint, but all other regions you can in AWS. So we have that worked into our tool. And then we plug in the bucket and the region. And then with Google Cloud Storage, there's just a single command where you, again, plug in the region and the bucket name. And then this next piece is a configuration for tools. So this is a configuration that we use in our code. So it serves two purposes. One, to tell the LLM what the tool is about. So we pass it a name, a description, and the parameters for the function. And we have a description and the type for each of the parameters. And then we also pass in a function pointer that I'll show you how we use later. And we do that for both functions.
And one thing to remember is like the description is very important here. Just like your prompt is important, the description in your tool is also very important for it.
Yes. All right. And then this little helper here is what turns it into the LLM format. So we add this input schema. This is just a JSON schema. So we have the object and the properties, which are more or less what we already had. And then we have the required properties here, which in this case is just all of them. And then here is the code where we initialize the client. We capture the input from the user. We call the LLM again. I want to call out two new things here. We pass the tools in, so that uses our helper function that formats them properly for the LLM. And then we pass this tool choice parameter where the type is any, and any means that you're forcing the LLM to call one of the tools. If you pass auto, which we'll show you in the next demo, then it can either call the tools or respond with a message. But in this case, we want the LLM to always call a tool. So we're passing tool choice type any. And then here we pass in the prompt the same as before. And actually one last piece, calling the tool. So when we get the response, now we're looking for content type tool use. And we use that function pointer that I called out earlier. So we use our tools dictionary and we pull out the function and we pass the parameters to the function. And the parameters are guaranteed to match our schema, so we're certain that it's going to execute properly. Now I'm going to pass it over to Dave to walk you through a demo.
Yeah, so the first example is very rudimentary. There's no checks or anything. Now we have a little more guardrails on it. We have a default configuration file. And for those of you like new to AI, if you don't like using YAML, LLMs are great at parsing Markdown files. So the first thing I'm going to do is create a bucket named O2. Because we already have prefixes in here, we already have default, I don't need to specify those. I can just say create a bucket named 02. That's all I'm doing. It shows AWS because the provider's AWS. Let's create this. Okay, let's take a look. Okay, it created it. And now all I'm going to do in this Markdown file, I'm going to change it to GCS instead. And now we're going to get the exact same prompt, except I had changed to provide GCS, and it should create the same bucket, but in GCS. So it shows GCS over here, GSUtil. Great, let's take a look and verify. Okay, cool. So if you notice from the output here, last time we only used 42 tokens. This time it was 850 because we're using two tools. We have the system prompt, we have the user prompt. So a lot more. The next demo, we're going to get into more deeper into details. Okay, it's all you, Dan.
All right, sweet. Thanks, Dave. Now, the next one is where we start getting into a more agenic workflow. So I wanted to go through just what we consider an agent. Agent has a ton of different meanings in the AI world right now, and it can mean a prompt pipeline, so a very specific workflow, or it can mean an agenic workflow where the LLM actually chooses what to do. But I think this diagram from Anthropic really nails it on what an agent actually is in the most simple way. So there's a human. The human passes some data. The LLM gets called. It returns a result to the human, and it can either stop, or the LLM can decide, oh, actually, I don't have enough information. Now I want to take an action, query an external environment, and get feedback. And it can continue to do that until it is finished, and then it'll respond to the human and stop. So that's what this last example is going to do. And let me walk you through the workflow that we have for the last example. It's a little bit more complex than that, just because we're actually diving into all the different details of what's happening. So similarly, we start up here. The user inputs a prompt. Here I have analyzed messages. Initially, we start with just one message from the user. We pass those messages to the LLM. It can either decide to call a tool or in the turn and return a message. If it decides to call a tool, which in this case it most likely will because we're asking it to perform a function for us, we process the tool. We also have three different tools in this case. So now we have a valid region check, a valid bucket name check, and we have the create bucket. And so for the two read commands, we don't actually require you to confirm. We assume, all right, we're just reading. We're not going to adjust the system in any way. No confirmation is needed. We execute immediately. But then when we go to create the bucket, we still want to confirm with the user that we're going to create the bucket. And then we execute or cancel accordingly. And then finally, if we decide to validate on our way to creating the bucket, then we'll come back through here. We add the result to the messages. The LLM will analyze again, and it will eventually create the bucket, and then finally exit. So now I'll walk you through the code to show you what that looks like. All right, so here's our new system prompt, very similar to the last system prompt. We're shifting focus to just AWS. We have three tools. We could also implement those tools for Google Cloud Service, opted not to. So here they are. Create bucket is valid region and bucket exists. And then there's a note about whenever we're going to create a bucket, we want to validate the region. And here are the tools. So we've also moved away from the CLI. Now we're using the AWS SDK. So now we don't even have to go out to a shell command, which is an extra layer of security. In this case, I'm just returning a string here as the response for the tool, mostly because it's simpler and the LLM can comprehend that. But what we could do is have a true or false value and then an error message. But really the reason that I wanted to return a string here was so I could return an error with an error message that the LLM could then respond back with. Similarly with the bucket exists, we check if it's valid, invalid, and we also will send an error if we get one. And then for create bucket, we do the US East 1 check again, and otherwise we add this location constraint. All right, here we're setting up the tools. Nothing new here. We're just setting up our new tools, except now we've introduced this requires confirmation attribute. And so at the create bucket, we have requires confirmation true, is valid, requires confirmation false. And this probably gives you an idea of how things like Cursor and Claude Code decide to execute tools as well. Some are automatically requires confirmation equals false. Some are true. And then you can imagine how they might add a safe list on that too. So if the user says, don't ask me about this particular tool anymore, you can imagine how they might set that up with a similar configuration. Here, this is actually the exact same helper that we had in the last one that builds the LLM version of the tool. The requires confirmation is all on our side. The LLM does not know about that. Here I've also pulled out the LLM request because we're going to go through this loop. So I didn't want to have to copy paste that over and over again. No new surprises here. We call the LLM, record the input tokens and the cost. And then here's finally the loop. We gather the user input. We create our messages that we're going to build up as we execute more tools. Then we go into our agenic loop. We make the LLM request. We append the response to our messages, so the LLM has all the context. If it's tool use, then we go through and we execute it. We look for all the messages with tool use, and we pull out the tool. Now I've started to format the tool so you can see when tools get run. Even when they don't ask for confirmation, you'll see that the LLM called it. So here we've formatted the tool call, then we ask for confirmation, and then here's the print that happens no matter what. And then finally we append the tool result here. And once we're done, we add it to the list of messages and go back up and make the LLM request again. If there are no tool calls, then we assume we're done and we exit. Now, this is not always what happens. So if you're building out an agentic system like a chatbot, then if there are no tool calls, it more or less means that you most likely either respond to the user or ask the user a follow-up question. So for example, in this case, we've removed the defaults. So if you just put the prompt in that Dave had before where it asks, oh, create the bucket with a 0-1 name, then it would probably say, oh, which region do you want it to be in? And that would actually not be a tool call. For this simplified version, we just exit out, but you could actually prompt the user again, capture additional information and append it to your messages and continue to send those messages to the LLM and it'll decide what to do next. All right, now I'm going to pass it over to Dave to walk through the demo.
Yeah, everybody. Now, the first series of prompts are going to be designed to test some of our tools directly. So the first couple of prompts, we're going to be testing the is region valid first, and then we're going to be testing the is bucket valid as well. So the first one is, it's real simple. Is Ohio a valid S3 region? So we're just going to test that. Again, it's going to convert the word Ohio into a US West 2. You can see 800 tokens for this one, about the same as the last. So it says, yes, it is a valid region. Let's test the next one.
So I'm going to call out a couple of things here, Dave.
Sure.
You can see that there's actually two executing calls. So first it calls is valid region with Ohio. And in that case, it's false. Then it calls is valid region again with US East 1. So it corrected itself based on the knowledge that is has about Ohio and the available AWS regions. And finally says, yes, it's correct.
Yeah, it's pretty awesome. I love this. Okay, now we're going to ask for, is Nome, Alaska a valid region? So we're going to find out. Okay, so you can see the answer is no. It is not a valid region, but it did come up with some regions that are close to it. So that's testing the is valid region. Now we're going to test, does this bucket exist in Oregon? So let's take a look here.
Yeah, and you can see for all these, we don't have to confirm anymore because these are all read commands.
So you look up here, App Vitals is a bucket, and it does come out in the region. So that worked pretty well. The next one is, I'm going to try and create a bucket that already exists, and we'll see how it handles it. We already confirmed it exists, but I'm going to try and create it here. Let's see. It should validate the region first, and then it should check if the bucket exists. Okay, there you go. So it already exists. So it's not going to create it because it was able to check, validate the region, and also validate, hey, that bucket's there. So I'm not going to try and create the bucket. I'm testing ahead of time. So we're getting a little bit more production worthy, right? Rather than make a mistake, we're checking ahead of time, right? So looking for. So we don't have any default set right now. So in the last example, we had default region set. We don't have that set right now. So let's try and create a bucket without setting the region. So if you remember, we have two checks here, right? Is valid region, and it won't do it, right? It's saying, before we proceed, we need to know which region you want to check it in, right? It's really smart. So we're getting closer to production level type things where we're not allowing mistakes to happen. So now
there's one other thing that I wanted to call out here, Dave, was Remember in the previous example, I passed tools any, which forced it to call a function. You can see in this one, now that we're passing tools auto into the tool choice, it actually doesn't call a tool at all, and it just says, I need a region.
Yep. Basically, because like the region was missing. There was
Yeah,
there was no region or nothing that could be thought of as a region, so it did not supply that.
yeah. And it's a required parameter to our
Yep.
tools.
Yeah. So now if we are getting closer to production, right? We have some guardrails, we have some validation in place, we have some safeguards. So now I'm gonna create a bucket. This time I'm gonna name the region, and it should go ahead and create the bucket for us. So it's validating the region, and then it's checking does the bucket exist, and because it passed the region and the bucket did not exist, it's prompting me to create the bucket. So I'm gonna go ahead and create it, and it's using Boto 3 this time, not the command line. So let's go take a look. And it created the bucket. As you can see, like the use of tools really gets you closer to more of a production hardened type of system. And we're just scratching the surface here.
Awesome. Thanks, Dave. That was great. All right, sweet. So that's it for this video. Just want to give a quick overview here. We started with a basic prompt that generated shell commands, no tools at all. You could type in, show me the files in this directory. It would happily do that. You could go tell it to go to GitHub, happily do it as long as you say yes. Then we moved to using tools to build commands for creating AWS and GCP buckets. And finally, we showed you how to leverage tools to orchestrate a workflow that allows an agent to validate and create buckets in AWS. So that's it for this one. By the way, if you need help with integrating AI into your business, you can check out the first link in the description to book a free consultation call with us to discuss how we can help. Now, if you found this video helpful, please leave a like and consider subscribing. Thanks.
Bye, guys.